He is also the Chief Technology Officer of Deloitte's U.S. Innovation Office, and works with clients in the federal sector, in the high-tech sector, in the financial services sector, deploying state-of-the-art technologies in their organizations. So I can barely think of anyone better than Mark to be conducting this interview today on the future of healthcare and AI. Mark is also a two-time graduate of the University of Georgia Bulldogs, which probably doesn't earn him many friends in this part of Texas. But we are certainly thrilled to have you here, Mark. So everyone give a warm round of applause, please, to Mark White.
I'll say to John that if I'm the best he knows, I'm going to be a better friend. I'm so pleased to be able to have the opportunity to do this today, and I'm honored to be able to actually spend some time across the table from Dr. Andrew Moore. Given the audience and the background of the audience, it's unlikely that he needs introduction. But I'll share a few interesting background items coming out of Carnegie Mellon himself, and then going to Google, which if you're a geek like I am, is almost a dream job. Whereas he said himself, he went from being a geek to being a businessman, a desk jockey, but he certainly put a lot of the technology behind Google Retail, Google Shopping, and some of the e-commerce work that was being done there. And by the way, systems that run globally, 7 by 24 by 365, which as an engineer and OR guy, that to me has some respect there. So if VP of engineering there, and then boomerangs, that's what we call it in the firm, when you come to Deloitte and you take that entrepreneurial spirit and you go out and do something else. But my consultant's curse, and Allo, where are you? My consultant's curse is always, I hope you're tremendously successful and equally dissatisfied, come home when you're ready, right? And so I guess perhaps you were tremendously successful, but perhaps equally dissatisfied and came home to Carnegie Mellon, ultimately to take the role as the Dean of the School of Computer Science, a prestigious position no matter how you would cut it, but made more so by the direction that he has set, both in growing the undergraduate program in computer science and sophisticating it, not sophisticating it into esoterica, but rather sophisticating it into its application in the real world of business and government today globally. So with that, let me introduce Andrew Moore and invite Andrew to the stage. So you get walk-on music, that's pretty cool. We had a team, actually, Devin, we did a hackathon, and the team had the weekend to build some highly immersive, engaging thing, and our team built a geofence app that when you walked on, you got walk-on music.
Oh,
yeah,
really cool.
Yeah.
Good.
Not very commercial, but cool nonetheless.
Yeah.
Good. Well, I don't know if you've seen Actors Studio before, if you've watched that, but that's where we've modeled this. I promise, however, that some of those very terse and awkward questions he tends to ask, I will avoid.
That's okay. That can be your best show.
Oh no, these are not nice questions. Yeah, if you've not seen this. So, but we're talking today, and as the introduction said, about AI, artificial intelligence, broadly, and then specifically down into the impact on healthcare, the provider, the payer, etc. And so I thought, in the South, a blivet is 5 pounds of stuff it's 10 pounds of stuff in a 5-pound sack, right? That's what a blivet is. You just keep stuffing stuff in and that 5 pounds. And so AI has become a bit of a blivet. The marketeers are now playing with the term. Tell me, what is AI? What should we think of when we think AI?
AI is always two things. It is systems which understand the world and then make decisions based on what that understanding. So that's the top level. If I ask someone to produce an AI system for me, I'm expecting that they will have some way of understanding what's going on in the world. So then they're working on their perceptions, their sensors, maybe they're learning algorithms, and that's not enough. At that point, you could implement that. That is a very useful analytical tool, maybe a useful visualization tool. But to be an AI system, you are automating decision making. So there are decisions on top of what you've learned. And you have a system which does that, and the decisions are impressive enough that you say, someone 100 years ago would say, well, only a person has the wisdom to make that decision, then you've got an AI system.
So Turing tested, and is that the implication?
No, nowhere near that far. So playing chess, we all know, everyone in this room knows that it's not rocket science. It is an algorithm which most of us understand, but that is exhibiting the kind of level which would have made a 1895 person say, oh right, wow, that is exhibiting human level intelligence.
Excellent, excellent. So the misapprehensions then that people are placing around AI, what would you say to them? Take this out of your head. So put in your head, understand the world and make decisions that matter.
Yeah.
Take out of your head.
Okay, you've got to remember there's an A in AI. We're not working on I. We're working on AI. Specifically, simulations or things which look like they're being intelligent. We're not implementing intelligence in any way. So, if I write a script for myself on my computer which just helps me prioritize the tasks that I'm going to do over the next few days, I might implement it in Excel or something, and it's useful enough that I say, wow, I'm really proud of this script. This is doing as well for me as a person might have done 20, 30 years ago when I've implemented a very trivial AI. So it's artificial intelligence. We are totally faking any notion of real intelligence here. It's just that these fakes are really useful, not just for playing chess, but for scheduling kidney transplants and keeping aircraft safe in the sky and so on.
So optimization, high combinatoric, stuff that is hard for me to sort out. Through. So you talked about understanding the world and making decisions that matter, and we think of that as cognitive analytics. We talked too about cognitive automation, and so Hodlipson at Columbia talks about this, and because he comes at it from a robotics standpoint.
Right.
What link do you draw between AI and robotics?
Very similar. When I go into more detail on what you're trying to do at the top of the AI stack. The AI stack you can think of as a set of technologies beginning from perception through to understanding the perception through to the vast search algorithms and speaking to folks as with an affiliation with Heinz College, the awesome OR algorithms that are out there. Then as you go beyond that and you start going to the application area, there I want to break up the application space into a spectrum. The spectrum goes between full autonomy, systems which are just like really trying to live by themselves without any input from humans, through the spectrum to what I would call full cognitive assistance. And these are the systems which are helping make us smarter, helping me make better decisions because they're providing me with advice and information in the way that I need it. So at the very top in the application land of AI, I want to draw the spectrum and be really clear about it. Because you get incredibly confused if you start to say, well, fully autonomous systems are the only real AIs. That's not the case. Fantastic AIs such as the things powering Apple's Siri or Amazon's Alexa, those are the ones which aren't making decisions for themselves. They're really helping figure out what you need.
Fascinating. And so the robotics piece of it then becomes, I guess that could happen anywhere along that continuum. Is that?
Yes, thank you. I evaded your question without any ill intent in my mind, just because I got so distracted by this important distinction. Yes, so the robotics part of this, once you're doing this with the physical world, as well as with the software that lives on the spectrum, just as the software lives on the spectrum.
Yeah. So goodness today, it's interesting. So sometimes we talk about business rules engines, backward chaining, basic stuff, text analytics, right? Basic pattern matching, and those are poo-pooed as not being AI. Your response would be?
They're actually an essential part of many AI systems. Now, it's easy and absolutely pointless to get all snooty about what's AI and what's not. again, I want to go back to this concept of the stack.
Good.
You cannot build a fantastic, say, human emotion recognition system, which most of us would regard as an essential component of a really strong AI, without underneath it having something which can track facial features and analyze voice features in real time. When you look at how you do that, you start to be going down to digital signal processing and GPU accelerations and the conversation we were having earlier about massive computation being distributed over multiple servers. Folks doing that, they're doing AI work to support the top of the stack. They've actually got a lot of responsibility below them. Now, when it comes to things like a keyword search, which for those of us who are proper nerds, we just say grep, or grep on a very big scale. I'm not going to sneer at that and say that's not AI, because in the most advanced dialogue systems at the moment, where you use a combination of a deep learned neural network and a bunch of search algorithms similar to A-star search algorithms for the advanced parsing, you've almost certainly had to use some of that keyword stuff lower down in the stack just to filter out a lot of misses. And so these things are all working together. And I'm not going to be upset that we're doing some things which might be called algorithms or numerical methods or OR tools, while we're solving the ultimate thing, which is developing a software system which is going to look to a 19th century person like it's being smarter than a typical human.
That's actually quite an excellent test, right? I mean, is this, if someone were to say to you, well, that's not real AI, and you go, well, don't be snooty, as I see the Cambridge word there, so
Yes.
they're doing that.
Okay.
Don't be snooty, is it in fact learning from its environment and making decisions that matter in a way that would seem to the 18th century expert as you?
Yes.
Okay, so here's how this works. The first time I steal that, I'll give you credit by name.
Okay.
The second time as an important client in front of the firm, after that it's just mine. Is that
That's basically okay, but believe me, if you get on the wrong side of the school of computer science, bad things will start to happen to you.
well done, well done. So that's a bit what's underhyped, if you will. What's overhyped? Where's the expectation being set too high so that we're going to get that trough of disillusionment?
Yes, we are, I believe, going to plateau soon for a while, maybe for 10 years, maybe for 50 years. Now, after we hit that plateau, we're still in a wonderful place where if we get our acts together, we can make the world safer, we can make people's lives more meaningful and safer and more interesting. So do not fear the plateau. But I'm really passionate about this, and this is something I learned from Herb Simon, one of the founders of the School of Computer Science, and one of the originators of AI in total. And to explain this, I would like to explain a geeky puzzle. It will take about 2 or 3 minutes. Is it okay for me to do that? All right, is everyone okay with me doing this? Okay, thank you. This is called the chessboard covering problem. And I'm going to give you a very simple problem, then I'm going to give you a hard problem. I don't want any props with me. Imagine I've just got a simple 8x8 chessboard, and I've got dominoes. And those dominoes are about the size where they will cover 2 of the squares on the chessboard, all right? I give a robot, or a 5-year-old, 32 dominoes, because there are 64 squares on the chessboard, and I say, cover the chessboard with dominoes. And a robot's going to do that. It might do a little search algorithm. It might unnecessarily search something which we see immediately. There's a simple pattern for doing this. That's great. Now, what I need to do now is give you another problem. I'm going to take away one of the dominoes. I'm going to snip off the diagonally opposite squares on the chessboard. You're nodding. You're probably seeing what's happening here. And I say, all right, with these 31 dominoes, I want you to cover the 62 squares remaining on the chessboard. And our current AIs would be very, very good at doing the search. It's a pretty big combinatorial search. So they would search and search and search, and there would be an algorithm where they would try to solve this. So this is meant to be fun, so I'm not going to put anyone on the spot. But if anyone wants to nod enthusiastically, they can indicate that they see what's going on here. this supposed AI will be working very, very hard to solve this problem. And eventually, and I haven't done the math, but I think even on just an 8x8 chessboard with a reasonable depth first search type of algorithm, it would take more than weeks. It would say, wait, I can't solve this. Now, thank you. Why am I doing something so geeky it really helps for people to laugh, even when it's completely irrelevant? Okay, and again, I don't want to put anyone on the spot to sort of try to figure out what's going on here, but certainly without wanting to seem snooty, an SCS grad would always think about this for a while, and after 1 minute, or 30 minutes, or a few hours, would notice, wait, here's something interesting. Those two diagonally opposite squares on the board, they were the same color as each other. I took off either 2 blacks or 2 white squares. Look at those dominoes. Those dominoes, when I put them down, they each have to cover 1 white and 1 black square. Wait, that means if I've got 31 dominoes, and they've each got to cover 31 white and 31 black squares, there's no way to do this. So that is real out-of-the-box thinking. And I will make the claim very strongly that we have no known technology for doing that kind of reasoning. I'd be delighted to find parts of universities or parts of corporations which were trying to work on those problems, but frankly we're not doing that kind of AI right now, because there's so much rich stuff to be done with the, what you might call the propositional level work of learning relationships with real value numbers, running our big optimization algorithms. We can transform the world with that. But these kinds of out-of-the-box creative thinking things, and it's not just really contrived puzzles like that. That's things we do in our regular everyday life. We have no known technology. So we can sit here and hope that some brilliant person is going to come up with that next year, and they might, but it might actually take another 50 years. I just don't know. So that's my biggest complaint about this assumption that we're on the inevitable march to someone who can do the job of, say, a human nurse or or a human educator, where these people are very creatively thinking around problems all the time in their lives. And sure, we can automate human chess players who are supposedly so smart, but that's just because they don't need to do this kind of lateral thinking.
You guys like that?
By the way, you can disagree with me. Anyone's welcome to disagree with me on this. I'm passionate about it, but I'm open to feedback.
So coverage questions are always difficult questions.
Yeah.
So traveling salesman, notionally incomplete problems, right?
Yeah.
Okay, I'm going to go. Sorry, Ron. Sorry, John. I'm going to go off the board.
Okay.
Right. So, what underlying technology breakthrough is going to change that game? I would propose that while general purpose quantum computing may be further out, that Google have just said they think that they'll get a high cardinality stable GPC in 5 years or less.
Yep. Microsoft also invested very heavily in that area.
Quantum optimization, so using the physics of the quantum machinery to do optimization against high combinatorics, that changes the game, right? So now pattern matching is done not exhaustively, which is what we would see, but yeah. Reaction, thought?
I don't buy it. I think something is out there. It's not like there's anything like mathematically horrible for this. Though you could argue that there's some halting problem type or Gödel theorem type problems sitting there. But I don't think those will be getting away. It is just the act of abstracting, taking a problem in one representation and saying I can put it into another representation and move ahead with that. It's possible, those of you who remember courses in logic and how you began with propositional logic and eventually went up to first order logic and then second order logic, and huge numbers of things which looked really nice and easy in propositional logic became frightening in first and second order logic. I think
the technologies that we're really good at now in AI are vast, massive propositional logic types of things, where we're using direct data. We're not, of course, we can embed simple rules and things like association rules and so forth. Which, yes, they're not that high level influence. Someone will do it. Many people, including some of the top folks in artificial intelligence, such as Pedro Domingos or Stuart Russell, have been wrestling for more than a decade on the idea of combining, truly combining propositional level probability and first and second order logic, so that you could make and infer some of these higher level things. I don't even know if that will be enough to be able to do this out of the box thinking thing. I'm not saying the out of the box thinking thing is impossible. I just don't see a clear path from where we are now to solving that. And if we just assume that, well, everything else seems to be working, so AI is inevitably going to get much stronger, then we will get frustrated when we plateau out on these fantastic systems that are just based on these propositional level pieces of work.
Thank you. So that was a very sophisticated piece of thinking, right?
Thank you. I pride myself on sophisticated thinking.
I don't even say erudite, because I don't get to use that word. Very erudite. However, you're quoted as saying one of the things that keeps you up at night is how you engage enough middle and high school students in this arena in order to make them not only aware and interested, but equipped and active. And you testified to the Senate around this, and you're speaking, I think, this evening on a similar topic. So how can we take that sophisticated and erudite thing and make that relevant and material in middle and high school?
Very, very good. So I want to be clear about something else which I think we all agree on. Even if we don't solve that chessboard problem or have the technology to do that meta-level thinking, there's a vast amount that we can do over the next few decades based on the kind of technologies that we already have and reasonable extrapolations of what they can do. So, if, as is quite reasonable now and certainly straightforward in 5 and 10 years, computer vision systems can really understand, I use the word understand carefully, if they can identify not only the 3D physical structure of the room, but actually do lookups according to Google searches on every object in the room and other information about what those objects are used for, under certain circumstances recognizing the people and what they're interested in, then 1 million current middle schoolers can each invent amazing new applications of that. One example which I just so new, there's been some recent breakthroughs in tracking the limb and arm movements of groups of people, dozens and in some cases maybe even hundreds of people, accurately. Now, I see that, and it's being used at the moment for really interesting stuff to do with analyzing the psychology of crowd movements. But give a kid, it doesn't have to be a genius 27-year-old, it could be a 14-year-old who knows enough about APIs, give them an API where they can actually set up their laptop or iPad watching a bunch of people dancing, and that kid can then start to invent a technology for noticing or giving tips to individual dancers about where they could do better or worse. That would be a fun thing to do with this technology. That's one random thing in my head. I want 1 million folks coming up with these kinds of examples. I don't want it to be the case that it's just 10,000 kids or students who are lucky enough to get to go to CMU or MIT or University of Washington or the other great schools. This needs to be democratized in a way that millions of people can now develop websites and web technology.
So Peter Diamandis says the 60s is deceptive, and then it dissolves, and then it demonetizes, and then ultimately it democratizes. That's some of the forces that we see as we look at the larger forces to see which we think might actually be exponential and impactive. That pattern and democratization that is becoming available to and relevant to, enabling and changing the lives of billions. Yeah? So what are you doing at the university level, at the undergraduate and graduate level now to begin pushing that down?
So I'm going to begin by saying I don't think we're doing enough, and we're not proud of ourselves. We have, by the way, this is what I take responsibility for. The university has done a fantastic job of a bunch of very important aspects of education. One of the things we're celebrating this year is that 48% of the incoming class of computer science students are women. 48% is 3 times the national average. We're really excited and happy about that. And needless to say, but I'll say it anyway, there's no difference in the quality or skills of the genders as we admitted. We admitted to the same ridiculous bar for everyone involved. But the 2 decades of work creating virtuous cycles where the culture worked for that were really good. However, now we lean back, only 2% more to go, and then we can relax. The problem with that is if we look at some of the other demographic indicators about our incoming classes, I personally am embarrassed. One of them is that we, the School of Computer Science, have far fewer students who are Pell Grant recipients, which is one of the markers for students who are first generation or coming out of communities where they don't usually get that level of access to a really advanced education. We are significantly below the national average in that. And the fear I have, and many of my colleagues have the same fear, is that we will start to see a world where some of us lucky ones, the folks in the high-tech industries, our kids get into the high-tech industries, and we'll get this sort of hereditary almost split of the techies and their hegemony of their techie kids and so forth, and then the folks who maybe don't even realize that it's possible to work in artificial intelligence because it looks like just an alien rocket sciencey thing which only 1 in a million people are qualified to do. So that's what we're worried about. So what we've started to do this year is, with the help of Mark Stellick, who anyone who's graduated from the School of Computer Science will know very well, one of our most beloved teachers, we're starting programs for us to put our courseware into some of the high schools. Notice I'm saying high schools, we're not yet ready to go back into middle schools, to train teachers to help the students get ready for or understand that playing with computers is not a massively complicated or difficult thing, and start to bring some of the parts of the CMU curriculum on computer science with appropriate transformations into something which 9th graders can feel comfortable with. This approach from Mark and also from Dave Cosby, another of our beloved teachers, is really trying to push the idea that in the 9th grade we want to see all kids learning the basics of computer science, enough to be able to not just write some Python or JavaScript, but to understand the basic concepts of things like recursion, structures, probability composition. Then we don't want to hassle them about it anymore. 9th grade, we're going to get you, we're going to make sure that you get to see this. After that, in 10th, 11th, and 12th grade, the big push is that in all the other things you're doing, art, history, physics, chemistry, math, you can get to use this. You get to use what you learned in 9th grade. We actually don't want to force all the students to be spending 1/3 of their time on computer science. We want to get across the idea that computer science is a useful tool. It's much less abstract and weird than calculus, for example, and much more actionable for getting stuff done in whatever area you're interested in.
I laugh. The physics students always said that about the math students, right? So the maths were just abstract and senseless. Physics is where it really hits the road and becomes relevant. And now you're saying, in fact, both of those might be slightly abstract. Why don't we hit the road at? You yourself actually said that you're a maths and algorithms guy and crap at the engineering and hardware side. Is that,
yes.
Did I get that roughly
yes,
right?
It's very much the case that somehow I do
not trying to build robots, but I'm 10 times slower than my colleagues.
So really, I think this idea of pushing from esoterica into the reality of it. I mean, we've had this huge lift technologically that has made things, but we talked about that. So computational and storage power, and then the huge vast availability of the digital data have changed this from paper exercises or somewhat abstract exercises into things that really work. The most applicable real-world problems today. So we talk about pattern recognition, reverse facial recognition, and the ability to build APIs for kids to do things that are cool.
Yeah.
Have you seen Second Spectrum, by the way, that came out of MIT that watches the basketball games and how you keep book on the basketball game? It does that.
Oh, very nice.
Yeah. And of course the recognition markers are very strong as the jerseys of numbers. What are the most significant industries or sectors or use cases in the near future? So Horizon 2, now to 24 months. Where should we see this impacting our world of business, of government, of academia, of real life? Great.
So, not to just pander to the topic, but I think healthcare is an early leader in this. You have been seeing this over and over again. The current main area, of course, which I do think you're going to see further things, is in the consumer mobile experiences. That's why basically every person with AI qualifications is being courted by the big internet companies doing consumer experiences. And this isn't just like the obvious Google, Microsoft, Apple, Facebook, Amazon who are doing these intelligent device agents. It also goes to Snapchat and Pinterest and other folks who are doing sort of new user experiences. So there, it's pretty straightforward to put in new aspects of better speech technology, better understanding of a situation, better understanding of what's going on in the person's voice. So that's one. Two, as the decision systems and especially the sort of technology side, the testing and test results in healthcare move forwards, that's something where I'd be really surprised if things looked in 5 years like they do now. Slightly slower is education. The use not of computers to replace teachers, but computers to help teachers really manage their classrooms with all the support they need. For example, one thing that an elementary school teacher, or my sister who's mentioned this, she's a middle school teacher, is just it would be really nice to have 25 pairs of eyes so you can be watching all the students all the time to get an idea of if younger students getting into trouble in some way or just losing interest in some way. Yeah, exactly. So these I see sort of pushing on next, and it's going to be, I think it's going to be a really exciting one as we improve education because of that has this meta effect that we're doing education better, population actually gets to participate in these high-skilled parts of technology.
Master, thank you. So at the risk of being dystopian, and I actually don't mean to be dystopian, but one of the sets of questions is around the idea of there are some troublesome bits. And I was talking to some of your team about Pittsburgh have autonomous vehicles, right? You've got the Volvos that are running around that are autonomous. And we know, in working in the government and transportation and otherwise, that there's a complex piece, which is if there is an accident, who's at fault?
Yes.
So we have this entire body of both law and lore and culture that says if a human is driving and unfortunately something happens, there's an accident, we know how to resolve. But there's licensure, there's insurance, there's law and policy, there's culture and custom. Now, if your algorithm is driving the car and there's some mishap, who's at fault?
So I do very strongly think that this is one of the reasons we need governance, because this is a classic situation where if the numbers are showing nationwide, suppose they were showing a 30% reduction in road deaths through the use of automated systems, but a 1% increase in unnecessary deaths. Now, I think that would be unacceptable. We engineers should be able to do a better job than that. But if it's not a 1%, if it's a 0.01%, then the country as a whole, or maybe it's a state, has to decide, this is good, this is worth it. And we do make these kinds of decisions. For example, when we're planning out the design of roadway intersections, there is a calculus there of, if we spend another $10 million, probably one fewer person will die in the next 10 years. And roughly it's at the $10 million level that we choose to say, well, we can't afford it, we're just going to have to let another person die. So we deal with those, but it does need to happen from a higher level regulatory body saying, putting in the legislation which allows in this case, a car company to do something which is overall going to help make people safer, but will have in some cases these tragic consequences.
So your analogy to the design of an intersection is I haven't heard that before, and I'm in these conversations quite a lot, but do I have a two-way stop? Do I have a four-way stop? Do I have a roundabout? Do I have a traffic signal?
Yes.
That's a bit of an escalation, and I spend orders of magnitude more to get smaller order of magnitude reduction. Very nice, very nice. So,
But just to be clear about the difference, usually, if we saved $15,000 on an intersection, and then someone unfortunately died 2 years later, you usually cannot tie that to, if we hadn't done this wouldn't have happened. Whereas the difficulty with the cars is you can absolutely go and investigate exactly what happened. And sometimes, as you described, there will be this vastly improbable pattern of leaves shattering over a street, which means that a 1 in a billion chance occurred, and that's what caused the problem.
right, and so the LiDAR picked it up as a person swerved, blah, blah, blah. Yeah, good. So let's go back to healthcare, because as you say, not pandering, but do address. So one of the immediate applications.
Just before we do that, I was wondering if the audience wanted to sort of respond to any of the discussion so far.
Comments, questions, rebuttals? And there may be a microphone.
I won't need one, that's okay.
Okay.
Is there going to be a point in time where AI will be smarter than the creators, and do we need to be concerned about that?
Great question. So in case you didn't pick that up, is there going to be a point where AI will be smarter than the creators, and do we need to worry about that? There might be, but not with any known current technology. Right? Serious about that. There's nothing stopping a group of researchers from trying to make an artificial intelligence which can do all of this very advanced abstract thinking. That is not available right now, but it could happen. At the moment, when you look at this question of the AI is cleverer than its creators, often this will come down to, yes, absolutely. An artificial intelligence which is meant to be counting the number of cars going down a freeway is going to make fewer mistakes than a human who was previously doing that job. So there will be places where there are jobs, such as our expert chess players, which we used to think were you had to have really good human level intelligence for, which aren't there at the moment. But there are other jobs, especially the ones which involve lateral thinking, where I'm not seeing a known technology at the moment. Not to say it won't happen. I would put it in the same category of, unfortunately, as people are working on new engineering materials and nanomaterials, someone could inadvertently come up with a material which ate the material around it and self-reproduce from point to out. Similarly, we have a risk that someone working in germ warfare could invent, though this is hard, but in theory they could invent something which perhaps either wiped out humans or destroyed our food supplies. So this is a scary century now that we're getting so technologically strong. I would put this as a legitimate concern among those risks. But it's less immediate. Similar to the other things, we currently do not have a known technology for doing that.
Good?
Yeah, just that that eventually AI might be able to create its own AI, which would perpetuate. So it's fascinating.
Yes, no, and there are places which probably will make a lot of people feel uncomfortable. We do have some wonderful work going on at CNU and some other locations to do with automatically finding bugs in the code, and some computer scientists are now looking at not only automatically finding those bugs, but automatically repairing them. And so, again, this would not work if we tried to do it right now. I would not invest money in a company which said it was going to do it, because it involves too many technological risks. But you could then imagine one day someone saying, well, it doesn't only have to debug the code, it can also optimize it. And at that point, it's going to look a little frightening. I will still think of it as a software tool, just like a compiler, but it'll look a little frightening when our software is actually improving itself.
Okay, two seconds. So the issue you raise is commonly known as a singularity event. Right? So there's this place beyond which we cannot see, but the storyline that goes with it is that AIs begin to self-advance beyond ourselves. They optimize. We are a suboptimal element of the universe around them, and therefore we get destroyed. Right? That's the dystopic storyline. I like your take on it, which is not impossible, but not with current technology. Go.
So if I may be so bold in the grand CMU tradition of pressing on one of your assertions to test it for cognitive bias, can you think of a task or some set of activities that 10 years ago you would have said that requires too much lateral thinking for a machine to do? And I think of driving, right? We would have maybe said that a decade or 2 decades ago that there's too much lateral thinking involved, the machine could never do that. Are there other examples that surprise you about what machines have been able to do even at this point?
Yes, I would agree with you that it is the case that which professions fall, if you like, has turned out to be very hard to predict. That, and especially now that it's what would traditionally be called a bunch of white-collar professions are looking endangered before some blue-collar professions. That is finally getting the attention, I think, of a lot of the traditional white-collar decision makers. So I am not going to claim that we can predict which skills or professions are the ones that are being automated away. However, the ability to drive a car safely, that is not the same as a general purpose system which is somehow decided to use all manners to survive by itself. And without any disrespect to cats or fruit flies, there are other systems in nature that we already know do not have this, to our knowledge, do not have this lateral. Yes, exactly. I agree.
Cat haters.
Yes. Okay, so let's go with fruit flies. No one really cares about that. They're able to perform these amazing feats of navigation, but we're not expecting to be doing this general purpose conversation.
That's a question? Others? Please.
So, one of the things that I've noticed is sort of a lot of the examples that have come up here, right? Counting cars on the highway, playing chess. You could argue that those things are very sort of, have very sort of distinct set of rules, and it's almost the application of a skill. So, slightly more philosophical question, like, what are you actually defining as intelligence, and how does that differ from a skill? So when you're kind of coming up with the definition of what really is artificial intelligence, how do we know it's not just an algorithm that sets rules to play a game or something?
So I repeat the question just in case, but it really was that the concern is that I've been giving examples of intelligence by these skills without which when we see their implementation, it looks like it's pretty much clearly just some pretty straightforward algorithm, as opposed to turning out to need anything like actual simulation of intelligence as we understand intelligence. And I really can't defend myself against that. The trick, and this is not an evil, intentional trick, but the trick is that what we generally label as artificial intelligence could be called advanced numerical analysis and optimization, or super advanced, no, not even super advanced, or algorithms. One of the big jumps that we made was these cases where it looked like we had really outdone human intelligence, like chess. You'll notice there weren't many of them, and those were in the 80s and 90s. And part of the reason that we got those first big results back then was we didn't have huge world models where we could look at much broader swaths of the world and make decisions based on them, because the computer didn't have access to the data. And so it was only these very subscribed domains where you had all the rules written down that you could do it. The big breakthrough, I believe, from 2000 to 2010 was the use of large-scale statistics and machine learning to model systems, so that now our optimization systems can, for example, schedule cars through a city, taking into account the likely traffic patterns that are going to be emerging in the next 20 minutes.
Thanks, Dan. That was good. You said, as we laughed, I asserted that the big difference in AI now than when I was at university is we did it as a paper exercise. Now we're doing it as a real-world application. Not only because of the computation and storage breakthroughs, but really mostly and truly because of the explosion of the amount of digital data to train the systems, because of the way I think about AI and neural nets almost always. And it will be, and your comment was, yes, you can't do big data without big data. So I give you that as well. There's existential threat to, Robbie the robot was existential threat to the blue collar, to the manufacturing workforce. Turns out it was not. In fact, it has been more amplification than it has been replacement. AI and this heavy rules base, so the ability to take a very complex canon of rules and apply it over a very large set of data very rapidly, repeatably, transparently. Right? That's what we're good at now.
Yes.
By the way, that's what an accountant is good at. That's what a diagnostic physician is good at. That's what a case lawyer is good at. So do we have existential threat to the white collar? And your answer is yes. So what do we do about that? Because by the way, I like what I do. I'd like to continue to do it, just for what it's worth.
I think it comes down to your earlier question of it's almost sort of unpredictable which of the skills which it turns out we can simulate without actually having to have invented some kind of genuine intelligent agent. So what we're seeing, for instance, in the legal world is that the parts of the job which are less interesting to do with quickly figuring out what are similar cases or how in the past this particular rule has been applied under these kind of previous things. Those are much more automatable. In this case, I'd be worried about paralegals and legal assistants, and maybe just a shrink in the total number of folks you need, because
What do new associates do? They look at case logs.
yes. And the lawyers who are already well established and having to do some of this lateral thinking to realize, hey, we can solve this whole problem by relocating this data center to Hong Kong instead of Venezuela. That kind of stuff will still be there, but they will have automated power tools to help them get all of the data to reach those conclusions. I've got a fantasy of, because I'm involved a lot in negotiations about intellectual property and research programs, I've got a fantasy of two folks who are trying to come to a deal, talking to each other just like this, and projected on the whiteboard behind them is a legal expert, well, not actually an expert, but someone who just plots out the state of the conversation and sort of plots out, these are the places where you guys have not yet agreed, these are the ones which seem to be covered.
And there are three historically common approaches to come to resolution, yeah?
So this kind of, that's a cognitive assistance type of thing, which I could imagine doing with some version of the current level of technology.
So we, in writing about this, and we by design in our trends speak to time horizon too. So things that over the next 18 to 24 months we expect to see in commercial and government use. And we wrote about AI and said, please don't think about it as artificial intelligence. So I appreciate your emphasis on artificial intelligence, the emphasis, if I will. And we said, let's think of it as amplified intelligence. So we take the human and make them available to do what they do best, which is deal with the exceptional, and routinize the routine things, which is this idea of the game squares being played behind us. Good? Yeah. I'm going to ask one more question, and then I'd like to bring up the lights and open it up. To make sure you get more food because they have overcatered. Thank you for that. That's not bad. Be cautious. The salsa is Texas hot. So if you Yankee eyes somewhat like I find I have, it'll be too hot for you. But I want to ask one more. So be thinking, if you will, about questions you might have. We'll bring the lights up and we'll take a little Q&A. I expose a bias around balkanization of media, particularly around certain issues, and Harvard Business Review did an article about the inherent risk of bias in the design, therefore deployment and action of these artificial intelligence agencies. What do we do? Is that valid, or is it the hysterical running about thing? And B, if it's valid, what do we do?
All right, I'm afraid I don't have a good answer for you. This is a real problem. This is not a hysterical media thing. A very thoughtful, careful, ethical computer scientist who is trying to avoid some of these concerns is pretty much stuck at the moment. And just to reiterate the kind of problem we're talking about, if you are giving people an automated system making loan decisions for folks, then it would be illegal and monstrous if that automated system used the color of your skin in determining that. And of course, no system I've ever heard of would actually do that. The problem is a machine learning algorithm can easily accidentally do that. And we probably could figure this out, but it turns out that there are real correlations in the data, not strong ones, but real correlation between silly things like the number of letters in your name and the tone of your skin. It's not completely independent. And so a computer who's already not been given any access to the color of a person's skin might still end up inadvertently using that relationship or using that as a feature in its decision-making system by doing something else, like the number of letters in a person's name. Now, what we have to do as we're rolling out machine learning algorithms is check them. There are certain classes of randomization check you can do to get some sort of degree of confidence that the system isn't inadvertently using something which would be illegal, or even something which we regard would be unethical in making its decision. So you can withhold certain pieces of information, see if it will make the same decisions, but it is actually a very difficult statistical problem. This is something which I might have laughed about 5 years ago and said, boy, this is an interesting problem. Someone should do a study on that. It's kind of cool. Yeah, that's right. But now it's just brutally real because it's pretty easy to notice correlations in a system which is making these decisions. But all I can say is, at least for me, it's not the case that I can say there's this like secure encryption method which you can use to make sure that the machine learning system doesn't do that. It is actually, in my belief, an open technological question.
So thank you for that. It's actually not a new problem in forming predictive ensembles today. So in trying to do predictive analytics, you use a collection of algorithms that are interdependent that then produce the predictive outcome. And in testing the ensembles, you have to test for those inappropriate biases. It just happens that we generally have humans who are testing for feature insertion, et cetera. when I've got AI sharpening AI, so the like reinforcement learning, right? Who's going to test for that? And the problem that nets themselves, as they layer up and become much more predictively successful, much more successfully predictive, they also become very opaque. So knowing exactly how it came to the answer.
Yes. If all our statistical models were based like they were in the 90s on 10 features of a credit loan request, that would be straightforward. But once you've got it going through billions, or you've got a model with billions of parameters, it's really hard to get to.
Thank you for that. An honor and very interesting and informative. Can we bring up the lights and bring up questions or comments, or if you're bold or above?
I can bring this to anyone that needs it.
And truly, can we turn on the lights, like house lights, so that we can see one another? I know there's a switch because it was on earlier. Please go ahead.
I guess two questions we could split them apart. One is very kind of future-seeking around the experience of as we integrate AI into healthcare. What does the experience look like? What things are going to change? What things are going? What do you foresee as problems that will be solved near term, mid-term, long term? And I got a more tactical brass tacks.
Very good.
Come back to.
So that is an interesting discussion. It's something we should probably have mutually among us, because it is a very hard one to really be accurate on. So instead, I'm going to tell you one of the areas that I'm really optimistic about, which I think is a realistic and exciting change. And that is, if you look at the whole life cycle of someone getting sick, getting treated, and then hopefully getting better. The start of that life cycle is something that I find really interesting. If you look at the web logs of search engines, about 8% of all queries seem to be people who are concerned about some sort of health problem for them or someone in their family. And the path for getting from there to, for that person, triaging, is this worth finding out more about? Is it something, if I'm in a rural area, I can afford to take time off to have looked at? Each part of that early path. These, without having to solve the huge sort of political, social issues of all of healthcare, I can see using the kind of consumer level technology that revolutionized how we navigate around cities, or how we book aircraft, which by the way has an implicit bias that all the population of people who just regularly book aircraft tickets. But that kind of technology, there's nothing really stopping us from getting to a point where you can get much better information on what to look at with symptoms, how to analyze visual or other information about the patient to more quickly make a decision on what to do. So while we're talking about all the horrors of the huge political situation with healthcare, the fact that we've got very, very expensive equipment in hospitals that we can't afford to, or we believe we might not be able to afford to run for everyone. There's some good news, I think, that some of those early stage things, without having to solve those other big problems, are going to make life much better in the healthcare world.
On the complete other end of the spectrum, I interviewed a young gentleman yesterday who was a visualization bachelor and an information technologist major at NYU, and he had no idea what job title he should put on his resume to look for employment. His portfolio was amazing. He had more experience for a 26-year-old than I've ever seen, and he didn't know where to apply his skills. So in the real world, how do we get the young people who are excited about this new initiative and want to have that impact? How do we get them into places where they can have that impact?
Wow, that's such an interesting question, because it is important. I'm kind of a traditionalist. I do not like inventing or carelessly inventing lots of new names for exotic sounding degrees because of the reason you described it.
probably most of you don't even remember this, but like 15 years ago there was a really cool word. It was grid computing, which I think is it was a synonym for distributed computing, but not quite. But it would be awful to be someone walking around with a bachelor's in grid computing right now. And I know that this might be controversial. I think the same might happen to the phrase data scientist. That's also another one of these things. So overall, my advice is, I'd like the folks creating these degrees to actually be very conservative about naming them, to the extent that at the moment we're moving, I think, into the case where you could have a successful specialization in computer science in an area like robotics or machine learning, because we've hit the point where there are millions of people being employed with those skill sets. But at the moment, I happen to be really excited about emotion recognition. I think it's an emerging massive field, but I'd want to wait at least 10 years before I created a degree, an undergraduate degree in emotion recognition.
So I guess beyond that, like, I feel like I'm in a generation that there's at least one generation younger than me, if not now a second generation. And I feel like that generation is coming into even education and the workforce already predisposed to computing and already solving problems mentally with computing type knowledge. But the workforce is not ready, is not receptive to that kind of thinking. So how can those young people who are pushing the tide of using technology to solve problems get an employer to pay attention to, as a biologist, I have a computer science minor. How is that important? How as an architect, I've got a information learning degree. How is that important? How do those people sell their skills and get into the workforce in a meaningful way?
So that's a very good question. So I am, and I think this is, by the way, is a very strong Carnegie Mellon value. We really do expect to see physicists who are great computer scientists as well. So one of my aspirations for CMU over the next 5 to 10 years is that it gets branded as the place where no matter what you do in your undergraduate world, you become an accidental computer scientist. Because I would like someone with a degree in architecture to get employed as an architect, doing exactly the kind of things they want to do. But I'm perfectly willing to have a future where we understand that they're not going to be employable if they're not also very comfortable around using computer science. So I'm much happier about the idea of it becoming an expectation in the first stages of resume sourcing and then the second stage of resume screening that there's some evidence of skills, not necessarily programming skills, but as you're saying, this sort of new skill set that confident, I'm going to say youngsters, who are not frightened of doing a mashup in a hackathon where they put 2 or 3 APIs together. Those folks, that skill, I would like to see it safely there on the resume, that this person has either formal education training or subsequently in their job done things where they've been happy to integrate and mash up computer technology.
So, may I speak to your question for a moment? Yeah. So 2 stories, one cautionary and one that ends with, let me give you my card to give to that person. Okay. Cautionary tale goes like this. It's actually a few years old now. A big law firm in New York. So big law firms hire new law school graduates, they're called associates, and they do what's called sweating the assets. So sweating the assets means God made the world with 2,180 billable hours in a year, because that's how many billable hours are, if that's how you do your work. And they bill those associates at 2,400 to 2,600 hours a year, which means they're sweating and they're getting a lot of that. So they bring in this new class of associates, they give them their normal caseload, which should have created both the value to the client and the billable revenue to the firm. And they're getting good value to the client, they're getting good outcomes, but the billable hours are quite low. And this goes on for a bit, and these senior partners are pretty professional at getting that workload down. And so they go to find out what's happening. And this class of L3s, these class of law school graduates, had come in with the expectation that they would use collaborative technologies, particularly Facebook and Snapchat, et cetera, to find things out. So they'd be given a problem to go find out what the default case law was, or to find out what they talk about diverse outcomes of lawsuits, to go find this stuff out. And rather than go to the law library, they'd go and just message their friends and get good answers back. And they were getting really good. So here's the problem. All their friends don't work for that firm. And it turns out, by the way, if a competing firm knows the questions that you're asking, they may have some sense into your case strategy. So that turned out to not be such a great thing. So that whole group of people came into a profession, which is a very staid profession, with this new thing that turned out to be disruptive. This expectation that I would need to share versus need to know. Cautionary tale, right? The firm had to stop it. The sad little land of knowledge management that we try to do inside of enterprises, but they had to stop it. Now the other side of it, which is Deloitte centric, so we hire somewhere between 20 and 30,000 undergraduates in the U.S. every year. Every year, we have to go find top grads, and so you said you had how many CNU? 400. That's like barely a good start. We need to do some better going on that. We hire some of the top business degrees. Now I'm a mathematicians operations researcher, so I'm a weird guy out. But we hire some of the top business degrees around the country. Right? We're day one schools. In our federal practice, and that's the federal practice is where I work. It's a pretty conservative practice. Our strategy and operations consultants, so the guys who are between new undergraduates and about 4 years into their career, we're running them through an entire curriculum around quantitative math skills. Literally to equip them to be quantitatively analytical in the core work that they do. So if I can get that right out of university prepped, where's Ron on that? If I get that right out of university prepped, that saves us having to run them through. I believe that you will see the expectation. We talk about STEM, science, technology, engineering, and math. Momentary side rant. STEM should be STEAM, science, technology, engineering, arts, and math. Science, technology, engineering, architecture, and math. Science, technology, engineering, anthropology, and math. Because the science, technology, engineering, and math about how we affect the world, right? The arts, architecture, and anthropology are how humans engage with them. And we need both of those things. And if you're not finding that the skill sets that you described this guy having are hot in the market, if nothing else, send them big consultancies because we are hiring them by the bucketful. Helpful? All right. Excellent. Last one. Come on. Strong. Here we go.
So one aspect, I think you all hinted upon it and spoke about the governance and regulations around it. More so security, right? And somebody would say in the 90s, making payments on the internet, people were concerned and we found a way around it. But how do you balance the advancements in AI with the security around it, right? So for example, in Pittsburgh, you already rolled out the autonomous cars. It's working great. I saw them, I came from the TOC this time and I was really amazed at seeing them literally on the roads, right? So how do you sort of go, you don't want to curtail the advancements, but at the same time you want to be cautionary, and how are private enterprises like us at Deloitte advising governments, or even universities advising governments on how to be ready for the change, but at the same time work with them hand in hand so that things don't go out of control?
So, as with many other things, the rule of law is actually very important, and it's the thing which means that we can make progress here where otherwise we couldn't. So a regular, and this is outside my area of expertise, but it is not legal to have an autonomous vehicle without a driver running on the streets of Pittsburgh right now. And so there has to be a driver. And my estimate is that that driver is actually responsible for the vehicle much more than just a small percentage of the time. Maybe it's 5%, maybe it's 15%. So it's only through the legal process of, again, this is not my area of expertise, I promise you, I'm an engineer / mathematician, but the legal process of some unit of government deciding to authorize this based on expert information and data that we would actually start to allow fully autonomous vehicles on the road. I know this sounds perhaps anti-small business, but I would regard it as incredibly irresponsible for a small startup to decide that they're going to just run a genuine autonomous vehicle without a human driver just to see what happens. So in the world of some of the big internet companies which are not doing safety critical systems, there's an ethos of write your software, ship it quickly, if it breaks, fix it. You cannot do that in safety critical systems. And to my knowledge, no one's actually trying to operate that way. So there is a different apparatus which may seem alien to the small company consumer folks, where our job right now is to kick local government and state and national governments into writing down rules of the game.
Thanks, John. Good. Thank you so much, Andrew. I thought that was a great conversation.